Okay, so kule video sizoprova formula geometric series, which is Sn is equals to a times r to the power n minus 1 all divided by r minus 1, where r is greater than 1. Okay, so from definition we know what a geometric sequence has the general term Tn is equals to a r n minus 1, right? Where the first term is T1, which is equals to, when you substitute T1 in this formula, a general term, so to look at T1 is equals to A, right? And then when you substitute T2, when you substitute 2, ukuthola second term, uzothola ukuthi second term is AR, right? And then when you substitute 3 in this formula, general term, uzothola ukuthi term number 3 is ARN. Sorry, AR to the power 3. No, AR to the power AR squared. It's AR squared. Okay. Take a step by step. Okay, CT term 1, we substitute 1 in the formula general term Tn. So T1 will be AR to the power, where I see n I put 1 because it's the first term, and then in over no AR to the power 0. We know with anything to the power 0 is 1. So here I'll have a times 1, which is just a, right? And then term number 2 will be, now I substitute 2 lapha ku n, I'll have AR to the power 2 minus 1, which will be AR, right? Term number 3 will be, I substitute 3 with a formula general term, I'll have AR to the power 3 minus 1, which is AR squared, right? And so on. Term number up to term number n, which is ARN, AR to the power n minus 1, right, all the way to Tn, which will be AR to the power n minus 1, right? So we know what it by definition, this is the general term, a geometric sequence, and then we want to prove what the formula geometric series is given by this. So sifuna ukuprove that when you are summing the geometric terms with geometric sequence, you will end up to this general formula here. Right? So when you're proving, you have to start from first principles. Without having this formula as a times Rn minus 1 divided by R minus 1, what is the definition of Sn? We know what by definition Sn is when we sum the individual terms of a sequence. So in this case, Sn will be equals to T1 plus T2 plus T3 all the way to Tn, right? So this is by definition. Okay, and then because we're dealing with the terms of a geometric sequence, we have calculated T1, T2, T3 all the way to Tn. So we can simply substitute those terms in the formula of Sn, right? So Sn will be T1, we calculated T1 to be A, T2 we calculated T2 to be AR, T3 we calculated T3 to be AR squared, all the way to Tn, which is AR to the power n minus 1, right? AR to the power n minus 1. So I'll call this equation 1. Okay, and then now the next step is we need to multiply equation 1 by r, right? So when we multiply equation 1 by r, we will have, so this is equation 1, right? So we multiply both sides of the equations by r. So when we multiply the left hand side of this equation by r, we will have r s n, right? And then now when we multiply the right hand side of this equation by r, we're simply multiplying each term on this sum by r, right? So here I'll have a times r, here I'll have ar times r, here I'll have ar squared times r, all the way to ar to the power n minus 1 times r, right? So now you just have to apply the laws of the exponents, which say that when you multiply the same bases, you add exponents, right? So for example, let's multiply a by r, so we'll have ar. Now we multiply ar times r, we'll have ar squared, because we're just adding an exponent because of this same basis, and so on. So I will have, multiplying the right hand side of equation 1 by r, I will have ar plus ar squared plus ar cubed plus all the way to ar n minus 1 times r will be ar to the power n. Okay, and then I will call this equation 2. Right, so now the next step is to subtract equation 1 from equation 2, right? So ukwenza ukuthi ingas confusing, let us rewrite these two equations where the like terms are aligned or are under each other, right? So write equation 1 and 2 with like terms under each other. Okay, so I'll start by writing equation 2. You'll see why in a minute, why I choose to write equation 2 first. So I'll write equation 2 first. I'll have I'll have rsn is equals to 0 plus ar plus ar squared plus ar cubed all the way to ar n minus 1 plus ar n. Okay, I hope you understand why I started with 0, and then here now I have ar n minus 1, because the term before ar n will be ar n minus 1, right? I hope you can see that part. And then the reason for putting ngokubhala 0 la is because ku equation 2 anginaye term a, so in place of term a I just put 0, right? Because now I need to write these like terms under each other. So me starting by 0 will make it possible to put like terms under each other, right? So now this is equation 2. Still this is equation 2, right? And then I need to write equation 1 with the like terms under equation 2, right? So I'll have Sn is equals to a plus ar plus ar squared plus, here I'll have ar cubed plus all the way to, and then we know Wuti Sn for equation 1 ugcina ar to the power n minus 1. So I will have ar to the power n minus 1, right? So now okay, this is equation 1 still, right? So now I have the terms, I have rewritten equation 2 and equation 1 with the like terms of equation 1 under the like terms of equation 2, right? So I have ar, I have ar squared, I have ar cubed, I have ar n minus 1. So isizathu sokuthi sibhalele ama-like terms under each other kwenza ukuthi izinto zibe lula mase si-subtract, because our next step is we need to subtract equation 1 from equation 2, right? So the next step is you subtract equation 1 from equation 2. So tuzothi equation 2 minus equation 1, right? So mawuthi equation 2 minus equation 1 uzominasa ama-like terms, right? So here I will have rsn minus sn. So I will have rsn minus sn, okay? And then here I will have, it will be equals to, here I will have 0 minus a, which will be just minus a, right? And then here I will have ar minus ar, which is 0, right? And then here I will have ar squared minus ar squared, which is 0, ar cubed minus ar cubed, which is 0, all the way to arn minus 1 minus arn minus 1 is 0 again. And then here I will have arn minus 0, right? I can just put 0 here. I will have arn minus 0, which is just ar to the power n, right? So the next step is we just need to simplify this, right? So we'll have rsn minus sn is equals to 0 plus 0 plus 0 plus 0 is just 0. So here I will have minus a plus arn, which I can rewrite as arn minus a, okay? So now the next step is to factorize on both sides of this equation, right? So now I need to factorize. So on the left hand side we see the common factor here is Sn. So I will have Sn multiplied by r minus 1. This is great and stuff. I'm sure we can factorize, right? And then Lago right hand side of the equation, the common factor is a. We will have a times r to the power n minus 1, right? So now we just need to divide both sides of this equation by r minus 1, because at the end of the day we are solving for Sn, right? So we have Sn is equals to, when you divide both sides of the equation by r minus 1, you will have a times r to the power n minus 1 divided by r minus 1. There you have it. This is your formula for a geometric series, okay? So the formula, the steps are the same for this equation, this type of geometric series where the common ratio is less than 1, right? So the steps are the same for this formula, a times 1 minus r to the power n divided by 1 minus r, where r is less than 1. The steps are the same, right? So yeah, this is how you do it, okay?